Okay, so I was talking about the height being 3.5 to 4.5 and 4.5 to 5.5. So 3.5 to 4.5, I call it as category as 4. In case it is 4 between 4.5 and 5.5, the category is going to be 5. In case it is between 5.5 and 6.5, the category is going to be 6. So this is the way in which height can be measured. Okay, so this is the way in which height can be converted into categorical attributes. So instead of calling them as 3.5, 3.6, so on, the height can be either 4, 5, or 6, 3 different categories. So therefore, 2 important subtasks: deciding how many categories to have, number 1, and number 2, determining how to map the values of continuous attributes to these categories. These are the 2 things that we have. So now we'll go into the details. So first we'll start with unsupervised discretization. So a very basic distinction between the discretization methods are going to be into 2. One is supervised and other is unsupervised. So in the supervised, we are going to have a class label, and when it comes to unsupervised, there is going to be no class label. There is not going to be any class label. So no, the target variable, nothing is going to be there. So in that way, so in the case of unsupervised discretization, it is going to be relatively easy. The technique is going to be relatively easy, but whether it is effective or not, we don't. The techniques used for unsupervised discretization are relatively easy. Okay, so here we are going to discuss about 3 different approaches for unsupervised discretization. Okay, so let me explain again that in discretization, we are trying to convert continuous value. We're trying to convert continuous values into discrete values. Continuous values are converted into discrete values. That is what is discretization. So here we have 3 approaches. Number 1 is equal width approach. Number 2 is equal frequency approach, and the third one is K-means. So the first one, equal width approach. This approach is going to divide the range of attributes into a user specified number of intervals, each having the same width. Okay, so they are going to be divided into the same width. For example, I have numbers. So numbers are going to be counting from 1 to 100. 1 to 100. So there can be any number of numbers. 10,000 numbers are there. Okay, so first 10, 1 to 10, I'll put as one group. Okay, one category. The next 11 to 20, I'm going to put as one category. 11 to 20, and so on, and what I'll get is finally I'll be getting 90 to 100 as one category. 91 to 100 as one category. So whatever numbers that are there, the width of the category is going to be fixed. So that is what is equal width. That is what is the meaning of having equal width. So this is one type of technique where equal width is going to be used for the category. Number 2, equal frequency. Equal frequency is going to be there. So as I've told you, I have some 10,000 numbers here. 10,000 numbers here. We are not worried about whether they are between 1 to 100 and all these things. So we'll be seeing to it that, so first 1,000 come to one category. Then second 1,000 is going to come to the second category. Third 1,000 is going to come to the third category, and so on. So we're going to have 10,000 10 categories, and we're going to see to it that same number of objects are going to come into each interval. Same number of objects are going to come into each interval. That is what is the second technique of equal frequency. And the third one is the K-means. And this K-means is a clustering method which we will be discussing later about it. And this also can be used for discretization. Let us not get into the details of K-means. We will be discussing about K-means later. So now let us look at an example. This is an example where unsupervised discretization is used. So this is the original data that we have. This original data we are trying to categorize into 4 categories. This original data is we are trying to categorize into four categories. So these two, this one and this one, they are the outliers. Outliers means which are not in the range, which are not in the range. For example, in your class, all the students will be having a range of age. All your students will be having a range of age. For example, there are two students. So, for example, if I say your class has students whose range is, let me say, if I'm not 18 to 20, let me say, for example. Okay, there's going to be two students. One student is of 10 years age, and other student is of 50 years age. So these two people we call them as outliers. These two are going to be outliers because they do not come anywhere close to the range. So that is what are the outliers. So this data that we have here is the original data. And these are the three techniques that we have used: 1, 2, and 3. So this technique is equal width discretization technique, and we have tried to divide it into 4 categories using the equal width. And here we have equal frequency discretization, and here we have k-means discretization. So these dotted lines that we draw here, are the ones which are going to distinguish the categories. One, so this is going to be one category. This is going to be second category, third, and the fourth. Similarly, here also one category, second category, third, and the fourth. Here we see one category, second category. We have the second category. We have the third category, and this is the fourth category that we have. So if we closely observe, k-means is the one which is going to do better discretization. Okay, if you have, you see here, equal width is going to is not going to get good results. And similarly, equal frequency is not going to get good results. But k-means has got very good results, and the discretization is going to be done properly using k-means. So after k-means comes the equal frequency, and then comes the equal width discretization. So this is the way in which all these three techniques of unsupervised discretization can be categorized, and k-means can be used in most of the cases. This is about unsupervised discretization. So now we'll get into supervised discretization. So supervised discretization is talking about the case where we have a class label. Unsupervised discretization is talking about the case where we do not have a class label. Supervised discretization is talking about the case where we have a class label. So discretization with the class labels, they produce better results than those without any class label. Naturally, class labels are going to be helpful in producing the better results. Okay, so we are going to use a technique called as the entropy based approaches. So now what is entropy? Entropy is talking about the randomness. It is talking about the randomness and the purity of a classification or of a technique that is going to be used. So entropy based approaches are one of the most promising approaches that we are going to use. So let us try to look at what is entropy. For example, we have a data set. So there are k class labels. So what I mean by class labels is, for example, if I'm trying to categorize gender, the class labels are going to be male and female. So that is what is the class label. So I write some features. So and so, and then that these features are met, then one is going to be a male, and some other features I'm going to say, and then that is going to be a female. This is what is going to be called as the class label, male and female. So that is what we call as class label. So let k be the number of different class labels. Okay, and mi be the number of values in the ith interval of a partition. Because what we are trying to do is we are trying to partition. We are trying to partition the data set into I partitions. So therefore, let us say mi be the number of values in the ith interval of the partition, and mij be the number of values that belong to class j in the interval I. Mij be the number of values of class j in the interval I. Okay, so therefore, what we are trying to talk about here is we are trying to talk about the entropy EI. Means we are trying to measure the strength, the appropriateness of the interval I. We are trying to measure the appropriateness of the interval I. Whether this this interval that I have divided is appropriate or not. That is what is the most important. So then the entropy EI of the ith interval is given by EI is equal to sigma is equal to 1 to k Pij log Pij to the base 2, where Pij is equal to Mij. Mij means Mij is the number of values of class J in the interval I by Mi, the total number of elements in the category in the interval I. Okay, so in this way, if EI is what is going to be calculated, and what we expect is EI to be very low. If EI is high, then that is not a proper interval that is going to be calculated. The interval is not appropriate. So what we want to happen is the entropy should be low. If entropy is zero, perfect. Entropy is going to be low. Higher the entropy, the randomness is higher. Okay, so that is what is very important. We don't want that to happen. So therefore, we want the entropy to be very low. So this is the way in which discretization is going to be done. For this is the way in which supervised discretization of categorical values of continuous values is going to be done. So this is about the supervised discretization. So after discretization, what happens is, let us say we have a few categorical attributes, and we think that these categorical attributes are too many values. There's a huge number of categorical values. Then what is going to be done? That is what we are going to discuss now. So categorical attributes can sometimes have too many values. That is what is to be taken care of. If the categorical attribute is an ordinal attribute, in case it is an ordinal attribute, means which has an order, means the order is very important. 0, 1, 2, 3. This is the order that is going to be very important. And then these are as good as continuous attributes. If the order is very important, then these are going to be as good as continuous attributes. So therefore, all the techniques for continuous attributes can be applied here, and these attributes can be further reduced into fewer categorical attributes. Okay, in the case where the categorical attributes are nominal, then we need some approaches. For example, let us see the departments in a university. In a university is going to have two departments. So for example, there's going to be CSC department is going to be there. Okay, so there's going to be EC department in there in the university. There is going to be arts department. Arts is going to be arts BCom. For example, BCom is going to be there because university all the courses run. BA is going to be there. These are all the different departments that are going to be there. So if we have, for example, 100 departments are going to be there, then what we are going to do, the CSC, EC, and all these departments will categorize into one category called as engineering. Then this BCom is going to be BCom, MCom. All these are going to be part of commerce. Then these BA and all these things, they are going to be into category called as art. So now what has happened is all these departments, they are now categorized into only three different categories: engineering, commerce, and arts. That is the way in which the categorical attributes with too many values are going to be reduced. So this is how we get fewer categorical attributes from a huge number of categorical attributes.